there's such a lack of awareness of what the problems are in very educated people, including government officials who are making the decisions. So this comes down to education and raising awareness, in particular in the people who are making decisions.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software.
Hello, and welcome to the Week in Green Software. I'm Kate Goldenring, and today we're digging into a theme that keeps coming up across the ecosystem, moving from ideas and standards into real runnable practice, while the energy reality of AI and data centers keeps evolving faster and faster. Joining me today, per usual, is Tzviya, my fantastic friend and colleague. We've got 4 topics to cover today, from the new Green Software Foundation Reference Implementations Repository to the latest SCI, or software carbon intensity for the web, to a couple of reality checks on AI infrastructure and policy in the UK today. Then we'll wrap up with, per usual, a quick run through of upcoming events. Before we get started, Tzviya, how has this transition from spring to kind of summertime been treating you?
It's a lot of ups and downs, right? We've in the New York area, we've had some unusually cold weather and unusually warm weather. You can see behind me, we have winter coats and swim gear, and that kind of summarizes how things have been here. How about you?
Yeah, I feel somewhat similar. This past weekend, I went to Cannon Beach on the Oregon coast, which embodies kind of spring to summer because it's a little bit foggy at times, so you're kind of cold, but then the sun will come out and then you're running into the ocean all of a sudden pretending like it's going to be warm, and there's elk walking around you. It's quite a strange biome to have elk on a beach, but it's a great moody spring-summer spot to visit this time of year.
I just get deer on my front lawn, so when I plant flowers, I have to make sure they're deer-proof.
See, that's nice. We don't really have a lawn. But either way, I would love to have some deer frolicking or elk frolicking around me.
I've only seen elk when I've gone hiking, like at Rocky Mountain, which was quite a while ago.
I do think that is their normal habitat.
I think it's great that we're talking about wildlife, at least they're still around.
Yeah, and on that note, let's transition to how wild the green software world is today, and how things are, I guess, maybe standardizing in a way that makes things maybe less wild. And in the brief overview I gave, I mentioned how we're going to talk about SCI for AI and SCI for web. So I just want to briefly discuss what SCI is first. For those who might not be familiar, SCI stands for Software Carbon Intensity. It is an ISO specification that the Green Software Foundation put out that helps us measure how much carbon is emitted by our software. And the formula is that SCI equals embodied emissions, so the amount of emissions from the hardware your software is running on, plus operational emissions, so the amount of emissions that is produced by the electricity needed to run your software. And that takes into account, regional carbon intensity. So if your software is running somewhere with a lot of sustainable energy sources, that'll be lower than if it's running off of natural gas or diesel generators, as we'll talk about. And SEI, one important part about it is you measure the carbon per functional unit of software. So you're going to measure how much carbon is emitted by some unit based on the use case you're in. So whether that's in the AI world, so an inferencing request, for example, or the web, such as clicking a page. And we'll talk a bit more about that. So that really brings us to our first topic, which is the Green Software Foundation has created a repository with reference implementations. So it's aimed at turning the standards, so the SCI standard, and some of the tooling that already exists in the green software ecosystem into working examples that people can actually run, test, and learn from. So the first implementation, reference implementation, in the repository applies SCI to AI for LLM inferencing. So this is a great signal that the project is going after real-world, high-impact workloads like LLM inferencing. And it's a bridge between that that statement of here is some specification to reality that is here's what it looks like in production-ish code. So I encourage everyone to look at this. There's a quick start where you can run against some fixtures that are in the repository, so you actually don't need to have an API token for some inferencing service, but you also can attach it to local models or hosted models and kind of test it out. And the specific example that it looks at is it demonstrates one example reference that it looks at is how a more concise prompt set can lower SCI. So it's showing that if you make your prompt more concise and more directed, it'll lead to fewer token usage, both on the input and the output side of things from an LLM, which leads to less compute being needed and less energy. It doesn't measure the quality of the output, I will say, but it does give a really good use case of how you can map SCI onto a specific scenario and show that it actually showed that with better prompting, they were able to reduce token usage by something like 46%, which led to annual cost savings of around $4,000. So I thought it was a very good example that put some really empowering numbers in there as well. Tzviya, I'm curious to hear your thoughts on it.
So reference implementations are really exciting. I come from the world of standards, and standards are the words, and sometimes built into the words are sometimes it's actually something that you can write a script based on the words in the standards, but it's not necessarily an implementation. And in the W3C where I work, we have a rule that you can't publish until you have what we call implementation experience, but that's not the same thing as a reference implementation. A reference implementation is generally the best case scenario of how something can be implemented. I have a lot of experience in the ebook world, which is so different from this world, but that's besides the point. Many years ago, an organization funded by the French government called EDR Lab created a reference implementation of the EPUB specification in a platform called Redium. Now, a lot of you have probably never heard of Redium, even if you're avid ebook readers, but at this point in time, every implementation of ebooks besides Kindle has Redium as its foundation. So that gives an idea of how far a reference implementation can go. And I have a hunch that a reference implementation of SCI can do that kind of thing, because so many people are excited about SCI, but they don't know what to do with it, or they do know what to do with it, but they don't want to do the work, or they go to their higher ups and they say, this thing exists, and they don't have the time to do the work because they're so busy with token maxing or whatever phrase you want to use. I'm being a little bit sarcastic here, but the point is the work's already done. And now people can build on it, improve on it, plug it into their tooling, and it's fantastic that this exists.
Yeah, and I think everyone learns differently. Some people like to read the standard, and other people like to clone a repository and run it. And I think this will help people conceptualize SCI better and immediately think, oh, this is how I could do it, and I'm going to contribute that reference implementation back as well. And so the repository is really built around making it easier for community members to contribute as well. From my part of the engineering space, I work within the WASI or WebAssembly Systems Interface subgroup within the W3C, and we build standards around what it means to run WebAssembly outside of the browser. And reference implementations are really important to the release process of WASI. So in order for a new release to come out, all of the features of that are comprised in that release must be implemented in at least 2 WebAssembly runtimes. Yeah. And so that really makes sure that these standards are feasible before they're even published. And that's been really powerful for the robustness of the standards. And both of those reference or example, both those WebAssembly runtimes, the maintainers are highly involved in the WASI spec. And so that just leads to a really good back and forth as well.
Yeah. Generally, the way people interpret implementation experience, which is the formal specification language, is having 2 real-world implementations. So that generally translates to a reference implementation. So it's great to see that SCI for Web is doing this, because that's the way that they're translating the concept of implementation experience. So not every standards organization does this. Sometimes it's just released into the wild, and there's hope that it will work. But when we see people actually implementing, it's great. And then the rest of the world can pick it up and adopt it as well.
Yeah, and I think that having 2 reference implementations at least might be a good goal for this repository. I mean, it's already halfway there, but it's almost of an example reference implementation in a way. And I think trying to set like a goal of 2 might be a good next step for the repository. I think it'll come naturally, but one to keep in mind.
Yeah, I do think it will come naturally. And one thing that I've differentiated over the years is that a reference implementation is sometimes done by the creators of the specification as here's the ideal way to do it, and a real world implementation is created by other people in the outside world, not the purist specification writers, but let's say you at your organization, at Akamai, let's say, because that's where Kate works, wants to create an implementation of SCI. When Kate does it at Akamai, that is a real world implementation, but when the folks at GSF do it, that is a reference implementation. So it's a nuance, but let's see what happens.
Yeah, and I think that a nuance is exactly why the WASI subgroup doesn't really have a reference implementation. It just has 2 real world runtimes, but they can be seen as references for other runtimes to build in those standards as well.
This is like my favorite thing to geek out about, right? Standards.
We love standards.
Yeah, so next time we'll have to talk about one of your favorite topics.
Yeah, because we're going to keep going. So, because our next topic is also about SCI, and it's even more in your wheelhouse because we're going to talk about SCI for Web. There's been an update for SCI for Web, and we're really moving. There's more momentum, and while SCI for AI is an ISO standard, it's a version of SCI that's specifically for AI that now has an ISO standard. SCI for Web is a documented vision, but it's not yet an ISO standard. And so Chris Adams from the Green Web Foundation published this past week the road towards standardizing SCI for Web into its own ISO standard. And it's has a working version already that's targeted for Q4, and really talks. Chris in this article talks about how the new initiative is to take the original design document and translate it into a spec. And the doc contains a lot of useful and fascinating information, such as the behaviors SCI for Web tries to incentivize, such as pagination and server-side rendering, and the personas that they're targeting. And so there's some quick links to dive into those sections pretty immediately. And Chris also emphasizes how important cross-organization collaboration has been and will continue to be between the Green Web Foundation, which Chris works at, and the W3C Web Sustainability Group, which Tzviya is highly involved in. So I would love to hear your thoughts on this and your thoughts on how W3C is looking at it as well.
Sure. So this is really exciting that Chris highlighted my group so much. I'm the director of sustainability at the W3C, and Chris and I set up a relationship between my group and the Sci4 Web group, where the Web Sustainability Group at W3C has formal input into Sci4 Web. So roughly quarterly, Chris shares some documentation from Sci4 Web and asks for input from my group. It's not just my group. We have chairs, Tim Frick, Inez Akrap, and Mike Gifford, and our wonderful editors, Alex Dawson and Rose Newell. And there are many other people in the group, and feel free to reach out to me if you'd like to join. We are working on a document called the Web Sustainability Guidelines, which we're hoping that it is going to become roughly equivalent to the Web Content Accessibility Guidelines, the WCAG, for accessibility. And we're on our way. We have a lot of governments who have expressed interest in it, and we have a lot of people who are already referring to this. So we have a set of guidelines that are broken down further into success criteria. And this is helping you, depending on your role, create a more sustainable web. So there's a set of guidelines for developers, a set of guidelines for hosting, UX, and product and business. And the people in our group are on that side of things, and the people in the Green Web Foundation are a little bit more into the metrics, and we have a lot of people who cross over. And the people who cross over are often in both groups. So even if my group doesn't offer any formal feedback, which sometimes we do, sometimes we don't, we have a lot of people who have feet in both worlds, offering feedback to both groups. And a lot of people, when this group in W3C was initially formed, thought we would be the ones creating the metrics, but that is happening in the Green Web Foundation, and we directly refer to the work in CipherWeb. And it's really exciting that we have these two organizations working together. And so if you want to know, for example, how to create a page that's a lighter weight page, you come to me. If you want to know how to measure it, what the intensity is, you go to the Green Web Foundation. It's not me you come to, it's the W3C. Sorry, I'm a little proprietary. So it's really nice to have this partnership and to have both groups working on this at the same time.
Yeah, so it sounds like if we were to map this to the SCI formula, if we're looking at the operational emissions of a web page rendering, we might go to the sustainability working group of the W3C to see what are some things I can do to optimize that rendering. And some of this is already referenced in the SCI spec that's a work in progress, such as like optimizing asset delivery and more efficient rendering and stuff like that. And those you've outlined. And then if you want to figure out, okay, how do I go about mapping this onto the formula? That's what the SCI for web can help you do. Is you see that your baseline is that we're not really, we don't have pagination, so we're not really efficient. So let's plug that into our first baseline SCI formula, and then we can implement some of these behaviors, and we'll see our SCI go down and kind of see the progress and measure it.
Yeah, and one thing that we are working on in the W3C group is what we're calling an impact rating, because people need to be able to have some gauge of what they're doing, even if they're not using CipherWeb. So we have, it's a kind of rough impact model created by somebody from the Green Software Foundation, Farshad Irani, or Fish, as many of us know him. And it's a rating based both on how long it will take to implement and a low, medium, high, or not applicable score of how much impact it will have. So we need to have some metric that is more relevant than like the AA, AAA scoring of WCAG, if you're familiar with that, but not an actual number that's tied to carbon, because we also have things that are tied to water, we have things that are tied to human behavior and things like that. So there is another scale that is not yet in the document, so don't look at it yet, but next week it's going to be added in there. We're in middle of the pull request. There's a ton of work in progress right now. I am working with the editors as we speak. There's lots of documents open on my computer. And there's a lot of updates that are rolling. So if you're interested in offering your feedback, we would love to see it. And I can provide some links in the show notes about how to provide feedback as well. And one other thing I'll mention, we all know Chris Adams here. He's the host of other Green Variables podcast and formerly of this one. If you're really interested in a new kind of process for creating standards, he did an episode of one of these podcasts, I have to remember which one, about how the new process that they used for creating this using an AI tool called Harmony. And it's really interesting because you often think, well, you're working on reducing your footprint using AI as a little sketch, but it's a really interesting episode. I'll link to the notes as well. I'll link to it in the notes as well. And they talk about how they were able to use Harmony to come to consensus faster, and it took a lot less time than they were expecting. So I'll add that as well.
Wonderful. Well, I think this is something to stay tuned in. Follow SCI for Web and follow the W3C's web sustainability guidelines as those evolve actively. Right now, I'm interested in seeing the high, medium, low impact scoring that you're going to publish soon. So with that, I think we can move to our third topic, which is a shift into AI data centers and policy around them. And we'll be talking about that for kind of the next two topics. It's just the impact of these data centers. To start, there is an article from The Guardian about how Scotland created in 2022 a plan for green data centers, an initiative for this. And the goal of this was to encourage the development of data centers. But if you think about 2022, this was pre-ChatGPT, and they did not define what green meant. Rather, they were focused on how Scotland has a lot of sustainable energy sourcing and is inherently green. And they didn't anticipate how AI energy demands would shape data center build out. So rather than using Scotland's local well-developed renewable energy sources, some of these AI data centers are using diesel generators. And last week, energy company representatives confirmed that more than 100 data center projects have requested gas connections. So this is indicating that they want to burn gas to power themselves instead of connecting to the more sustainable local grid. And part of this is because there's a years-long wait to connect to the pretty highly strained already national grid. And this just speaks to the fact that there's momentum that's being incentivized more than sustainability and greenhouse gas emissions reduction goals. And in order to get these data centers out, we're basically jumping through hoops and just firing up some diesel and gas. And the impact of this is quite great.
Yeah, thanks, Kate. When I read this article, I immediately thought of a talk that I listened to earlier this week. Dr. Sasha Luciani, and I'm just going to say this, Sasha, this is your weekly call out, gave a talk at the Turing Institute called Making AI Truly Sustainable from Environmental Costs to Social Impacts. And one of the things that she talked about is that there isn't actually a definition of what a data center is. So it's no surprise that we don't have a definition of what a green data center is. And it's just another pitch for standards. We don't have definitions. We don't have a taxonomy. That doesn't mean we have to sit down and write a taxonomy of data centers. It means that we need to work with governments. We need to work, I don't know who we is in this case, but there is a need for a technical understanding at the regulatory level, and it needs to be rapid. We've heard, I've heard recently of the call for action. We're focusing too much on metrics and not enough on action. I had an almost absurd conversation with one of my colleagues this week. He said to me, I had a conversation with Meta about blah, 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 involving AI. And did you know that they're facing some obstruction to their data centers? And he was looking at this as a negative point. And I said, yeah, I'm aware of that. It's actually a good thing. And the opposing viewpoints, just with one of my colleagues, and after a short conversation, he was aware, he came to the understanding that this is ultimately positive, and it didn't take much convincing. This is a very smart person, and I'm not actually sure he thought it was negative, but it's just there's such a lack of awareness of what the problems are in very educated people, including government officials who are making the decisions. So this comes down to education and raising awareness, in particular, in the people who are making decisions.
Yeah, and the way I hear that conversation potentially having gone is someone being concerned, like, we need this data center, and you pointing out, hey, we need to make sure we have capacity and planning and sustainable resources for it. We can't just bring up all these data centers immediately and do it right. And I just think that's an important conversation to be had. And the US has set a not great precedent of these off-grid gas generators. There is a quote from another Guardian paper that just talks about the UK's issue with this at large of these off-grid gas generators, about how 11 US data centers have been built to serve Meta, OpenAI, Microsoft, and XAI, and altogether they reportedly emit more carbon than the country of Morocco. And now we're having other countries start to use these off-grid gas generators to expedite data center build out, and we're just going to have more and more carbon emitted, and bigger and bigger countries are going to be represented in these stats of how much emissions are created by these data centers that rely on these gas generators.
Yeah, sometimes I hear bigger than Morocco, sometimes I hear Denmark, and at a certain point it's going to be bigger than, and it's going to get to be like France, or, you know, the countries that it's bigger than are going to get bigger and bigger.
Yeah, and I think it's interesting because policymakers are in a hard position here. But there was one comment by Eleanor Warburton, who's Ofgem's Director of Energy System and Development, who basically was saying, like, we're working on connecting people to the grid as fast as possible. Connections are being delivered, but the system must work better for projects that are viable and ready to proceed. And basically it's signaling that, like, policymakers are trying to get connections to the grid faster so that they don't have to use these data generators, and they're in a hard spot because, you know, they want the economic gains of these data centers as is proposed, but they also, you know, have these limitations. So it's interesting to hear the wording that some of these policymakers and officials are using.
Yeah.
With that, I think we can transition to our next topic. And this is an interesting one. It's hyperscalers are backing a shared data center tech accelerator. This accelerator is called Elemental, and Google, Meta, Microsoft, and Amazon are backing this accelerator to pilot sustainability tech across shared infrastructure. And it's interesting because this kind of collaboration could speed up the creation and deployment of efficiency and measurement improvements in data centers. However, we really need to see this come to reality, and whether these investments in this accelerator will lead to technology that's actually used. One thing that I found interesting is that I don't know numbers well, but I do know the amount of money that these companies are investing in data centers is absurd. And this accelerator, they've invested across all these companies between 500,000 to 5 million per project, and up to 10 technology startups through 2027. So up to $50 million for the next year or two. And to me, for four hyperscalers, that doesn't seem like enough money to have a big impact. But I do not know, 50 million is a lot of money, but for a bunch of startups, that might not be enough if we're trying to improve, to find discovers and concrete innovation to make data centers more effective at cooling. That alone seems like it would be quite an expensive endeavor.
So I don't know that much about how funding generally works when you're working with accelerators. I am a little bit familiar with it. I don't know if they're going to work on scheduled funding or that sort of thing, but I would hope that if this is successful, they'll start funneling more money into it. I have both hope and skepticism for this. My hope is that these companies can indeed work together. There are areas where they work together. I work for the W3C, which is a royalty-free organization where all of these organizations, as well as dozens of others, work together. This is not that, though. Right? I always sit at the table with Google and Apple and Microsoft and many organizations that you've never heard of, and it's wonderful. We get along, we're friends, sometimes we don't get along, we generally come to consensus, though. That's our goal. Kate, you've experienced this also. I'm really curious to understand what the agreements are. How does this work? If somebody pitches a startup that has carbon shifting and do they pitch it? Is it like Shark Tank? Who gets the startup? Does it go to all of them? Is this going to evenly distribute the technologies across these 4 organizations? Is it open source? I really want to get into how this works. I think it sounds amazing if it can actually work in that sort of way. And it seems like a really great way to inject funding into clean technology. I'm just so curious about how this will actually play out in reality.
Yeah, it's interesting. I think so. The article says that they've worked with Elemental, the accelerator, to scope technology priorities and structure the effort, and it will evaluate and will help evaluate and deploy solutions going forward. So, what does help evaluate solutions mean? Like, how involved are they in selecting the candidates for acceleration? Is an interesting one. I also think the category that these projects have to fall under was broader than I was expecting. So they're focused on technologies that have applications beyond data centers, not just scoped to data centers. So it won't lead to advancements in solutions that are really tailored, such as chip level cooling efforts, rather more broad efforts like building cooling improvements. So they see innovations related to concrete, steel, water use, and other pieces of data center footprint as more of what they're prioritizing. And that could help, reduce their scope 3 emissions. And those improvements are translatable to other industries such as healthcare and education. So I thought that was interesting that they're trying to have the solutions expand beyond their industry. Though I wonder if that loses the opportunity to have like hyper-tailored solutions for specific data centers.
I have the same reaction. Like if we're talking about, improving sidewalks or improving the walls of a building, which is truly important, right? We're looking at scope 3. But if we're not figuring out how to cool data centers, or if the focus shifts from cooling technologies and chip technology and all of the stuff that is truly, perhaps the biggest problem that we're facing now. I don't know. I don't want to say the biggest. I don't know what the biggest problem is, but it's definitely up there. There are problems that need to be solved, but maybe that can be at Y Combinator instead of at Elemental. I don't know. I don't know if Y Combinator focuses on that. But it does feel like there's an attempt to get into the Y Combinators of the world and focus a little bit more on the hardware aspect of things, which is great. I don't know if there are accelerators for... I'm not familiar with... I'm sure there are. I am not familiar with the startup accelerators for hardware as I am for software.
Yeah, and they are focusing on building cooling initiatives. That is what they're saying. But it's all buildings, it's not just data center buildings. And so it could have a cascading impact in a good way. But I do personally think there's a lot of really interesting hardware innovation that could happen. And maybe that's also harder to fund because there's a smaller set of companies that are focused on hardware and that's more research oriented. And they want to focus on initiatives that are easier and more cost effective to spin up, such as ones focused on other categories. Definitely would be interesting to dig more into.
Yeah, I'm really curious to see where this goes. And I also feel like this is an opportunity for the existing accelerators to recognize that there's a huge opportunity here.
Yeah, and one thing I will say is they scoped the funding to 2027. That's a really short timeline. And that kind of speaks to that they want to know what projects were selected by then. And so I think this is not something where we have to wait 5 to 10 years to understand what they're prioritizing. I think it'll be really interesting in a year or as projects start getting funded to see what they're prioritizing and see, interpret what impact could actually be made.
Hey, if you're applying, we invite you to come on and tell us about your project.
Yes, that would be amazing. Okay, new list of guests to bring on. We will be following this deeply. Every time we see a project, we will find you on LinkedIn. And that was our last topic for today. So I think with that, we can transition into events. And this is a really big line of events, mainly because Green I/O is going everywhere over the next few weeks. We'll have, before Green I/O on June 8th in Edinburgh, Web Going Green is having a meetup. And then we'll have Green I/O in Amsterdam from June 9th through 10th, which Tzviya and I were in Green I/O New York recently, and those events are always lovely ways to connect with other people in the green software space. Highly recommend it. Attached to that Amsterdam event is the Green I/O community meetup event, June 9th through 10th. So recommend looking at that as well. And then there is the Who's Going to Save Us from the Energy Use of AI? You are. So a call to action meetup June 17th in Brighton. And Sustainable IT Impact Summit is happening June 23rd in London. Following that is Lean Agentic AI is happening in Karlsruhe, June 23rd. And finally, to close it all up, Sustainable Tech in the Age of AI, June 29th in Hamburg. So a lot of these are focused on sustainable AI and what that means and exploring that topic. That was the overarching topic of Green I/O in New York. So it's something that people are really trying to think about how to grapple with AI and sustainability goals. So with that, that's it for this week's episode in the Week in Green Software. We covered turning standards into runnable code with the Green Software Foundation reference implementation. We looked at the push to make SCI for web a real and usable and an ISO standard. And we had a couple quick important reminders that AI-driven energy demand is forcing both policy and infrastructure to catch up. Thanks for co-hosting here, and thanks everyone for listening. A final reminder that all resources for this episode are in the show description below, and we'll add some of those links that we mentioned. And you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. We will see you all next episode. So bye for now.
Thank you.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.